So we're going to start with a hypothesis test on the population mean where the standard deviation is known. This is not a problem from the book. I couldn't really give a problem from the book because there weren't that many. So here we're saying that we're going to suppose the mean weight of king penguins found in the Antarctic colony last year was 15.4 kilograms. In a sample of 35 penguins, same time this year, in the same colony, the mean penguin weight is 14.6 kilograms. Assume the population standard deviation is 2.5 kilograms. At a 0.05 significance level, can we reject the null hypothesis that the mean penguin weight does not differ from last year? Okay, before we can do anything, we can always write down the given, no matter what sort of hypothesis test it is. So let's write down some given information. What do we know? Well, we know what we're going to be comparing it to. This was the mean weight last year. So this is going to be mu naught, 15.4 kilograms. I won't bother writing the units, of course. This year, we took a sample of 35, and the mean weight was 14.6. And the population standard deviation is 2.5 kilograms. So my sample size is 35. My x bar is going to be 14.6. And sigma is known, the population standard deviation, that's 2.5 kilograms. And the last thing I'm going to have to know is I'm going to have to know the significance level. So that's going to be alpha. And that's going to be equal to 0.05. Okay, so our first step is we have to figure out what sort of hypothesis test are we doing. We have to state the hypotheses, but of course that also entails that we know what sort of hypothesis test we're doing. So we're going to state the hypotheses. Well, we know that the null hypothesis, we know what this is because we're testing if the weights do not differ. So we're testing if they're not equal. So this automatically tells us that the alternative is that mu is not equal to mu naught. Okay? Remember, what we're testing for is always the alternative. That's important to understand, okay? So the alternative is going to be what we're testing for. We're testing to see if they're different. We're testing to see if they're not equal. Okay? Because remember what we're doing is we're testing the null hypothesis. Okay? So this is telling us what we're testing. The test of the null hypothesis is the alternative, okay? So this is that mu is equal to mu naught. And I don't even have to put mu naught because I know the value. Okay, so this is that it's not equal to 15 point. So this is telling me that I'm going to do a two-tailed hypothesis test. Okay, so this is important. So we're doing a two-tailed hypothesis test. Because the nature of the tails is where I'm testing for. So I'm testing to see if they're not equal to 15.4. So I could be testing above 15.4 or below 15.4. Too far away on both sides of 15.4 is evidence that it's not equal to 15.4. Okay, now I'm going to have to compute my test statistic. Okay. And this always has the same form. It's x bar divided minus the mean minus mu naught divided by the standard deviation of x bar. So I'm going to go ahead and I'm going to put one more little thing here before I get into this. I'm going to put that sigma is known. Therefore, standard deviation of x bar is what I'm going to be computing. Okay, so this is going to be equal to by the central limit theorem, the standard deviation of x bar is the standard deviation of x, which is sigma, divided by the square root of n. And that's my sample size, which is 35. Okay. And there we go. And I'm just going to round this off. Okay, so that's my standard deviation of x bar. So now my test statistic is always going to be the same. My test statistic is just equal to x bar minus mu naught. In other words, I'm seeing how far my estimate from mu actually varies from what I think mu is, divided by whatever I'm taking the standard deviation of x bar to be. Here I actually know what it is. When we don't know sigma, this is the estimated standard deviation of x bar. Okay, so let's go ahead and do that. So my x bar is 14.6, my mu naught is 15.4, and the standard deviation of x bar is this. So this is the value of my test statistic. Okay? So this is saying that my x bar is roughly 1.9 standard deviations below the mean. And again, I'm just going to format that off. There we go. Okay, the third step is I'm going to compute the p-value. Now I have to know the distribution that x bar comes from. Okay, I'm going to compute the p-value. And really what I'm doing is, this is like the percentile that the data value is in, but I have to know the distribution. So in order to do this, I have to know the distribution of my test statistic. And what I'm going to use is I'm going to use the fact that the central limit theorem says when n is greater or equal to 30, then the test statistic is distributed like a standard normal. Okay? So this is an important piece of information. And I'm going to use the fact that when I'm also doing a two-tailed test, whoops, the p-value is going to be equal to 2 times the percentile from my data value. I'm sorry, percentile from my test statistic. Okay. And so we know this is going to be a standard normal, so I'm going to go ahead and I'm going to say that the p-value is equal to 2 times. And basically, I'm just going to find the percentile for this, assuming that it's from a standard normal. So here I'm just going to use norm.dist. Okay, this is my test statistic. I'm claiming that it comes from a standard normal, so the mean is 0, standard deviation is 1, and we want the cumulative. And so that's my p-value, and usually we want to round this off. Now I'm going to apply my decision rule. And this is easy. If p is less than alpha, I reject a null hypothesis. Okay, so if p is less than alpha, reject h naught. And if p is greater than or equal to alpha, we fail to reject h naught. Well, clearly this is the case. Okay, so this is true. So we're going to fail to reject h naught because 0.06 is greater than alpha, which was 0.05. Okay, so we're going to fail to reject h naught. And finally, we have to state our conclusion. So we simply say, at a significance level, you could say 5% or 0.05, either one's okay. Oops. We find there is not sufficient evidence to conclude the weight, the average weight of the, what were they again, penguins? Yeah, king penguins. Oops. In this colony is different than .6. So we're saying that we fail to reject. In other words, we say there's not sufficient evidence to conclude that the alternative is true, and the alternative is that it's different. This is similar again to a court trial where when the prosecution loses, right, that's when H1's people don't believe H1, the alternative hypothesis. A lot of times the judge will say they haven't met the burden of proof. Okay, in other words, there's not sufficient evidence to conclude someone is guilty, because that's the alternative. So here there's not sufficient evidence to conclude that the means not equal to 15.6. Okay, that's pretty much all the steps for the hypothesis test when sigma is known. And next we'll look at when sigma is not known.